Hi, everyone. Thanks so much for being here today. I'm Malavika, and today I'm going to be speaking about why Kubernetes security is a team sport. During today's talk, we'll take a look at some of the challenges that organizations face with cloud security, and then take a look at why network security is such a critical component of any cloud security program, and why it's such a powerful tool for cross-functional collaboration. But before we begin, because you might be a little bit sleepy from lunch, why don't you just, and we're talking about team sports, so let's start with just saying hello to someone next to you, introducing yourself. I know some people are groaning in the audience. And so while you all do that, I'll do a quick introduction to myself as well. So I'm Malavika, as I said. I'm a product manager at Tigera, and we maintain Project Calico. At Tigera, I'm helping build cloud-native networking, security, and observability tools. Professionally, I'm really passionate about open source software, user experience design, and machine learning. Outside of work, I love my 6-month-old son. I'm a former amateur boxer, and I also love dressmaking. Fun fact, I made these trousers. And you can come find me during the mandatory fun pizza session later today, and we can chat more. So a quick introduction to Project Calico. Who here in the audience has used Calico in the past? Awesome. I love to see so many hands. As you may know, we're really a ubiquitous tool for Kubernetes networking and security. There's a lot of numbers here on the screen. We power over 1 million clusters at over 50,000 organizations across literally the entire world. We're used by over half of the Fortune 100 in production contexts. And as I said, sometimes you look at these numbers and they feel apersonal. But actually, when I stop and think about it, I'm really humbled, and I'm also humbled by all the people who raise their hand, because that actually means that the software that the community and all of us are building is running in your cluster as a privileged pod, and you're entrusting us with your application's reliability and security. So thank you for that trust. And so that brings us to our talk today. Why am I even speaking about teamwork in the context of Kubernetes security? So according to Snyk's 2022 State of Cloud Security report, 77% of organizations cite problems with poor training and collaboration as a major challenge for cloud security. 77%. That's 3 out of every 4 people using Kubernetes at scale are saying, we have problems with poor training and collaboration. That number makes me really sad, because actually that's something that we can overcome. And today we also heard talks about empathy, and we heard talks about teamwork. And so I think that the more we can do to work together effectively, the more we can do around any kind of leadership training and coaching on that, let's do that. And so that's part of what I'm here today to talk about. So when it comes to working on a team, the first question is, who's even on our team? Who's responsible for securing cloud-native applications? And it's currently the Rugby World Cup, so I can't give a talk about team sports without a rugby reference. Do we have any rugby fans in the audience? We do. How many of you are actually England fans, though? Oh, a few. I got lucky today. I was worried that someone's going to come beat me up. A Welsh person's going to come beat me up. Good thing I'm a former amateur boxer, right? But anyway, so we have 3 types of engineers who are responsible for Kubernetes security. We've got developers, DevOps or SREs or platform engineers, and security engineers. Out of curiosity in the audience, who here identifies as a developer or application developer? Awesome, quite a few hands. And then how many of you identify with DevOps, SRE, or most of the hands in the audience? And then how many of you identify as security engineers? Oh, we've got quite a few security folks as well. So developers are kind of like wings. They move fast. They might break some things along the way. They like to ship really quickly, score points on the team, right? And so that's kind of how developers are, right? And then your DevOps teams, they're more like your 9s or your 10s. They're responsible for deploying the application, running the platform. They want to keep everything running really smoothly, like a well-oiled machine, so that the developers can ship fast, so the wings can go then score points, right? And then last, we have our application security team. They're really like a good defensive player, like a lock, right? They're here to kind of secure and protect your application. But what's kind of tricky, actually, if you're on the security team, is you're responsible for the security. You're responsible for securing the application code, securing the platform, but you don't actually control any of those things. So actually, you have to lead through influence. And how do you convince all these other stakeholders to collaborate and cooperate with you? I don't know do these challenges, and have you had these kinds of problems in the past, struggling to get people on other teams to collaborate with you? So you've probably heard of DevSecOps. Some Gartner analyst probably coined that a few years ago, and now everyone has to use this. It's considered a best practice to embed security into all stages of the software development lifecycle, rather than tack it on the end as it had historically been done. In particular, there's this concept of shifting security left, right? And you can kind of see it in this diagram, shifting left. But really bringing security into the build stage of software development. But many application security vendors would have you think that members of these 3 teams were all holding hands, were super excited to be patching vulnerabilities, and focusing on security. But the reality really isn't that. I think at the end of the day, while we want to build secure applications, we all have really different goals and responsibilities. It's not that we don't all want to work together and help each other, but we're all really busy. We have so much on our plate. So what's getting in the way of working together effectively? I think we're all well familiar with the challenges of alert fatigue. I think, I've got this chart here from Orca Security, but there's just thousands of vulnerabilities today. I mean, I think there's just so much more than we could possibly resolve or manage. And so, what do we do with that? How do you move forward from that? And then there's the issue, are your vulnerabilities even relevant? Actually, based on a recent Datadog report, they found that only 3% of vulnerabilities that had been flagged as critical were actually critical vulnerabilities when analyzed with runtime context. As a developer, can you really trust that you should be spending time fixing everything that's been flagged as a critical vulnerability, when actually maybe only 3% of them are really critical? Is that the best use of your time? And as a developer, did you really join your company to be making security patches? Probably not. You want to be building and shipping cool new software. So how do we move forward from this? Does the platform team just let you push your code into production? Do we just hope and pray that vulnerabilities don't get exploited? But probably not, right? I think this is not such a serious issue if we take a defense in depth approach to security, right? And what we mean by defense in depth is really that we have many different layers of security. So even if one fails, it just isn't foolproof, we still have protection in other ways. And so here, as you can see on the slide, I think there's what I think has emerged as 4 key components of any cloud security program. And there's much more than just these 4 components. But I think today you could probably agree that across the software development lifecycle, we do kind of code scanning or image scanning, configuration security, network security, and then some sort of runtime monitoring, threat defense. And if we go to speak to anyone today, many of you running Kubernetes at scale in production, I think you'd be hard-pressed to find anyone who's not already doing some form of code scanning, image scanning today. I think that almost every organization I speak to does that. And similarly, I think almost every organization does some form of configuration security. But I think people have had mixed success with that. I think configuration security is a tractable problem. That's something people have had reasonable success with operationalizing. But when it comes to, as we saw with all the alert fatigue from kind of your code scanning, image scanning, it's a little bit difficult to really figure out how best to move forward from that. And so what you can then use are tools like network security and then runtime monitoring of threats. But we see much lower adoption. In particular, since I'm talking about network security today, I actually find it quite fascinating that only about half of the Calico user base is really using Calico policy. That's kind of crazy, actually. Only half, because it's such an important part of cloud security. And then of those people using Calico policy, even fewer of them are really using it in a way to like really bring security and engage developers in that process. And so I want to make that number 100%. I want everyone to be able to use Kubernetes network policy and Calico policy. And so that's why I'm here today. And so why am I really excited about network security? I think it's just such an intuitive, low-friction, Kubernetes native way to bolster your security posture. It's really intuitive for anyone to write a network policy. It's really easy to write the YAML for that and set some guardrails on how your pods should communicate. And it's free, right? Like you don't have to pay any money for this. You don't have to pay any security vendors. You can just use native Kubernetes network policies, or you can use open source projects like Calico or Cilium to specify network policies and integrate these policies into your GitOps workflows. So what's a network policy? We saw an example earlier this morning from Liz on network policy, but just to recap. So in the Kubernetes network model, we have a flat network. By default, all pods can communicate freely with any other pod in the cluster. There are no network restrictions by default. We know that this isn't great from a security perspective. We don't want any workload to talk to any other workload in the cluster with no controls. The modern security best practices are really to implement a zero-trust network architecture, which really means that pods should only communicate with other pods when they absolutely need to. So if we want to only allow workloads to talk to workloads they need to talk to, we can do that really easily with network policy. We define a set of rules around what pods can talk to other pods, and we can use labels to specify these network policies. We can define those in the Kubernetes API, and then those are applied by the CNI plugin as close to as you can get to the actual pods. And we saw a little bit about this in some of the earlier talks. I know I'm glossing over a little bit about what network policy is. And so let's take a look at an example of a network policy. And this is why I'm so excited. It's really easy. You can actually just taking a look at this, we can see that this is a standard Kubernetes network policy. It's called Blue policy, and it's applied to the production namespace. It applies to all pods that have this key value label pair, color blue. And what we know from all of this YAML is that it allows ingress traffic from all pods who have the label color red on port 80. And so let's just let's go a little bit further than that. And we can extend actually basic Kubernetes network policies with Calico. So you might know Calico as a CNI, but we also provide Calico policy, and it doesn't require use of the CNI. Calico policy, it's all open source. It's an extension of Kubernetes network policies. And there's some key extensions here, like policy ordering and precedence, an expanded set of actions, more extensive match criteria, and the ability to protect things like VMs and host interfaces. But what's really exciting, and particularly I think around the policy ordering features, what I think is really exciting about this is it makes it really easy for developers, platform engineers, and security analysts to actually collaborate together on security. And so let's see what that looks like in practice. And so before we do that, I'll just show you kind of what a Calico policy looks like. On the left-hand side here, we've actually just rewritten the same policy we had before using Calico policy. So we've just re-implemented the same thing. It looks almost identical, but you can see that the API is slightly different. On the right-hand side, we've got a little bit more sophisticated of an example. Here we have a global network policy, and this means it's applied ahead of all other kind of normal Kubernetes network policies. We've got an order number here. It's making use of those deny and allow actions, and it's also allowing you to match on service accounts. And I won't go into too much detail on this, but I don't know if you can see this really well. It's very tiny text. But the idea here is actually, once you can do things like policy order, you can actually start to get multiple stakeholders involved in writing security policies. And this is actually really exciting from a collaboration standpoint. Before, I think when you had that world, before DevSecOps, usually an application security team would write some firewall rules and put that on your perimeter of your application. But actually now, we can make use of network security and in like a much more kind of intuitive way by using things like Kubernetes network policy. And then with policy evaluation, with policy ordering, we can then actually give the security team the ability to put overarching policies that can be kind of applied before and after some of the Kubernetes network policies that each team is specifying. And each team knows, I mean, I think, you know, all developers are really smart. They know what their services should talk to and shouldn't talk to. They're probably the best people to know how their services should behave and should interact with other services in the cluster. And so let's give them the power to specify those firewall rules. And we can actually see this in practice. So here we've got an illustrative example. We've got a few different services running in a Kubernetes cluster. And then, oh no, we've got some malware. We guess someone's exploited one of those vulnerabilities. And all of a sudden we've got some rogue service running, and you know, it's trying to make exfiltrate some sensitive data and send that off to a command and control server. But actually, because we have network policy, we can really limit the blast radius of whatever kind of exploit had been exploited and limit the impact of this malware because we actually just have some guardrails in place. And maybe that pod can't actually speak to the backend service. That pod can't go off and then make you know, some sort of outbound request to the C2 server. And then actually it's not so bad then. And so that's really why I think it's so powerful. And as we saw, it's actually it's really easy for anyone to write a network policy. And so that kind of brings us back to our rugby analogy, right? I'm super excited, right? Yay! Yeah, hopefully England will be winning something for you England fans. But I think, you know, I hear some groaning. Yeah, right. But anywho, I'm really excited about this because it's as I said, it's so easy for developers to do. And you know, I spent a lot of time speaking with folks in the Calico community, and I think it's really exciting when I speak to application security teams, and they're like, we got hundreds of developers to collaborate with us and cooperate, because we're able to use Calico policy and use it at scale. And it really allows people to, you know, achieve the kind of shift left idea and bring developers into the fold, but also in a way that's not taxing and difficult. And so for me, I think that's really a win-win situation, right? And it's such a game changer, and hopefully the more of you that can use Calico policy or any kind of Kubernetes network policy or its extensions, hopefully we can bring that 77% number down and collaborate more effectively together. And so with that, I guess I'll ask, is there any questions in the audience? Awesome.